All right, so here we got a couple of examples of going between angle measures that are in degrees and in radians. Now, what I will say is that it is infinitely important to have all of these pretty much memorized. I mean, you can get them all from just one of them. If you know that 180 degrees is equal to pi radians, then you can figure out the rest by either multiplying or dividing both sides of this equation by either 2, dividing it by 4, dividing it by 6, dividing it by 3. But it's really helpful to kind of have all 6 of these guys memorized for the most part. So let's take a look at our first angle, 3 pi over 4. I mean, this is a really weird looking angle. The first thing I would do to this guy right here is I would actually rewrite this as 3 times pi over 4. Now, pi over 4, that's something we know. Pi over 4 radians, that's 45 degrees. So if we want to put this in degrees, this is just going to be 3 times 45 degrees for a grand total of 135 degrees. And we're done. And what's really nice is actually for every single radian measure, we're going to be able to take that same exact strategy. So for instance, with our second one, I think we can write this as 7 times pi over 6. All right, pi over 6, that's 30 degrees. So we've got 7 times 30 degrees. I'll write it with a degree mark to make it very clear. 210 degrees. Awesome, awesome, awesome. 3 pi over 2. 3 times pi over 2. We know that pi over 2 is exactly 90 degrees. So I'm going to make a habit of writing a little degree mark whenever I'm in degrees. And if I don't, we'll assume that we're in radians. Also, the pi kind of gives it away. So I think we've got 270 degrees. Last but not least, 5 pi over 3. Really weird looking angle. I think we can write this as 5 times pi over 3 radians. And pi over 3 radians, that is 60 degrees. And so we've got 5 times 60 degrees for a grand total of 300 degrees. Awesome, awesome, awesome. So going from radians to angles, I find actually a lot easier than going from angles in degrees to radians. Sorry, I find going from radians to degrees easier than going from degrees to radians. So let's check this guy out. And I think we got a lot of options for these. So when I see 120 degrees, I say, how can I make 120 out of any combination of these guys? And we got a lot of options. For instance, some people like to say, oh, you know what? This is equal to 90 degrees plus 30 degrees. Some people say, you know what? This is equal to 2 times 60 degrees. Some people even say, you know what? I think this is 4 times 30 degrees. And you know what? Whatever suits you, whatever you would prefer. So for instance, I know that 90 degrees is equal to pi over 2 radians, and 30 degrees is equal to pi over 6 radians. Now, with a little bit of fraction work, we can call this 3 pi over 6 plus pi over 6 for a grand total of 4 pi over 6, also known as 2 pi over 3 when we reduce that fraction. All right, let's see if the other ways give us the exact same outcome. So 60 degrees we know is pi over 3, so 2 times pi over 3 gives us 2 pi over 3. Is that the same? Awesome, 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 awesome. We get the exact same angle measure in radians, and just for good measure, I think in this case, we've got, our last case, we've got 4 times, well, we know 30 degrees is pi over 6 radians, and so we end up with 4 pi over 6 radians, which, as we would hope, reduces to 2 pi over 3. So awesome, feeling good about it. All right, used up a little bit of space with this guy right here. He's kind of jutting in the way, but I think we'll make it work either way. So I'm looking at 225 degrees, and that's a really big number. I'm a little bit shaky on what its factors are or whatnot. So the first thing for me is I say, you know what, 180 degrees is pretty darn close to 225. And so you know what I'm going to do? I'm going to go ahead and rewrite 225 degrees as 180 degrees plus 45 degrees. And luckily, both of those are our go-to angles, ones we know. So I think we've got pi radians plus pi over 4 radians. So I'm going to rewrite this guy as 4 pi over 4 plus pi over 4 equals 5 pi over 4. And this tells us, oh, you know what? This must be, since I know that pi over 4 is 45 degrees, it must be that 225, oh, you know what? It's also equal to 5 times 45 degrees. Oh, and we can use that. And then also we could rewrite this as, well, 5 times 45 degrees is the same in radians as 5 times pi over 4 radians for a grand total of the exact same thing, 5 pi over 4. All right, we're going to do these next two a little bit more quickly. Now, note to self, 300, I guess we kind of, oops, I already did that one up here, but alas. We could write 300 as 5 times 60 degrees. 60 degrees is pi over 3 radians. 5 times pi over 3 will give us 5 pi over 3 radians. Are there more ways to do it? Sure, you could call it 10 times 30, right? 300 degrees is definitely 10 times 30 degrees. 30 degrees we know is pi over 6 radians, so 10 times pi over 6 radians. 10 pi over 6, and we can reduce that fraction, as we hoped, to 5 pi over 3, the exact same thing. And we'll do one more for good measure. 240 degrees, oh man. You know what I think? I'm thinking that this is equal to 4 times 60 degrees. So that's 4 times pi over 3 radians for a grand total of 4 pi over 3 radians. Were there other ways to do this one to get 240 degrees? Absolutely. But I'm kind of out of space, so I'm going to leave that to you.